Hello and welcome to this video brought to you by Smart Edu Hub Mumbai. In today's video, I shall explain to you how to write numbers in their standard form. Now there's a basic rule for writing numbers in the standard form, that is a into 10 raised to n, meaning any number that is given to you has to be written in the form a into 10 raised to n, where n means it can be any positive or negative integer, and a must only take the value such that 1 is less than or equal to a and a is less than 10, meaning a can take any value from 1 but it cannot take the value 10. That is what it simply implies. Now let us take a few examples directly from the past papers. For example, this question has been taken from May June 2002 and that's paper 2 question 1. The question says Javed says that his eyes will blink 415,000,000 times in 79 years. Write 415,000,000 in standard form. Okay, so you are supposed to write it in the form of a into 10 raised to n. I told you that's the rule. The rule is a into 10 raised to n, where n can be a positive number or a negative number. It can be a positive integer, negative integer, and a has a special rule. 1 is less than or equal to a, but a is always less than 10. Now that means the number that you will be writing, this number a, should be between 1 and 10. It can be 1, but it has to be less than 10. Now 415 can be written in a standard form as 4.15. Now this number has now become less than 10 and so it is fine, but then I need to write it in a way such that it is back into this form. So how will I do that? It's very simple. It's the basic calculation you must have learned in your lower years. So you're going to multiply it by some power of 10 that will get it back into its original form. Now that means I'm inserting the decimal point here, so I need to count right. Okay, so this is 1 2 3 4 5 6 7 8. That means if I write this as 4.15 into 10 raised to the power of 8, I will get the number which is having a value equal to 415,000,000. So this is what I've done, is I've written number in the standard form. Okay, so my final answer is 4.15 into 10 raised to 8. Okay. Let us take another example. Now this question here is taken from May June 2004 paper 2 and that's question number 10. We will directly deal with the 10b part because we are not interested in now identifying how to write numbers in the significant figures. That's what 10 is asking us. So I've already written the answer to the 10a as 80,000. Now we have to write the number 80,000 in the standard form. Like again I told you, the rule is you have to write the number in the form a into 10 raised to n, where this a has a limit. 1 is less than or equal to a and a is less than 10, and n can be any positive integer or it can be a negative integer. So with this in mind, let us change this 80,000 into standard form. So that becomes 8 because 8 will be less than 10, and to bring it back to the 80,000 form, what we'll do is, if we are writing this as 8, ideally what does it mean? It means that we are writing it as 8.0, right? So let us write it as 8.0 rather. So then this becomes 8.0 into 10 to the power of, now point is here, we need to see how many jumps to the right. 1 2 3 4. So there are 4 jumps to the right. So we write it as 8.0 into 10 raised to 4, and that's the answer in the standard form. One more question has been taken from May June 2006. It's paper 2 and question 1. The planet Neptune is 4496,000,000 kilometers from the sun. Write the distance in standard form. Again we need to write this in a way such that it will be in the form a into 10 raised to n. So it has to be in the form a into 10 raised to n, where n is positive or negative, and it's a positive negative integer rather, and a is anything which can be equal to 1 but less than 10. So straight away we can write this number as 4.496, and then we need to see that if I put a point here, how many jumps are we going to take to bring it to the form that has been given. So it means 1, 2, 3, 4, 5, 6, 7, 8 and 9. That means it is going to be 4.496 into 10 raised to the power of 9. Okay, let's take another example. Now this question has been taken from May June 2009, paper 2-1 and question number 14. There are 10 raised to 9 nanoseconds in 1 second. Okay, let me write this down. So 1 second, in 1 second there are 10 raised to 9 nanoseconds. Find the number of nanoseconds in 5 minutes. Okay, 5 minutes. So we need to first convert these 5 minutes into seconds. So for that we write down that 1 minute equals 60 seconds. So 5 minutes equal 50 into 6 seconds. So if 1 second is 10 raised to the power of 9 nanoseconds, so 50 into 6 seconds is equal to x. That means what we'll do is we'll write x is equal to 50 into 6 into 10 to the power of 9. So 5 into 6 is 30 and 30 into 10 is 300. So what we are going to do is we are going to write this down as 300 into 10 raised to 9 nanoseconds. But we need to write the answer in the standard form, and therefore we will write this as 3 into 10 raised to 2 into 10 raised to 9, which gives us 3 into 10 raised to 11. Remember the rule of indices, a raised to m into a raised to n. So 10 raised to 2 into 10 raised to 9 is 10 raised to 9 plus 2, which is 11. So our answer in the standard form is 3 into 10 raised to 11. Now this question has been taken from May June 2010, paper 2-1 and question number 5. Here they are telling us calculate the value of 5 into bracket 6 into 10 to the power of 3 plus 400 bracket close. Give your answer in the standard form. Okay. So the only thing that you need to do is you need to plug in the values as they are given in the question, and when you do that you get a calculator display which says this entire thing is equal to 32,000. Now in the standard form, meaning you need to convert this into something that is less than 10, that is 3.2. Now when you write this as 3.2, you need to ask yourself what will you multiply this 3.2 so that you get these 3 zeros back. Okay, so when you multiply this by, let me see how many 10 to the power of how many, okay, how many zeros. So now 1, 2, 3 and 4. That means you need to multiply 3.2 into 10 raised to 4. When you multiply these two, you get the answer back as 32,000, right? So your answer in the standard form is 3.2 into 10 raised to 4. Remember, why are we doing all this? Why are we multiplying 3.2 by 10 raised to 4? Because in maths we cannot change the question given to us. We cannot write 32,000 is just equal to 3.2. We write that into 10 raised to 4 to bring it back into the original form, which is 32,000. And that is true with all the sums, all the questions of maths. You cannot change questions. Whatever you do, see that you bring the questions in the original form always. Now this question has been taken from May June 2010, paper 2-2, and that's question number 6. Change 64 square meters into square millimeters. Give your answer in standard form. Now there's a little bit of conversion. So first we need to change these square meters into square millimeters. Before we do that, let us establish a relation between square meters and square millimeters. We know 1 meter is equal to 1000 millimeters. So 1 millimeter into 1 millimeter, which is 1 square millimeters, is equal to 1000 into 1000 millimeters square. That means 1 meter square is 10 raised to 6 millimeters square. So now when we know that 1 meter square, when I say 1 meter square, it is the same as 1 square meters. Okay, so I can say 1 square meters also. So 1 square meters is equal to 10 to the power of 6 square millimeters. So 64 square meters, okay, is equal to x. And you know that is equal to how much? That x over here is equal to, so x is equal to 64 into 10 raised to 6, which is 6.4 into 10 raised to 6, which is equal to 6.4 into 10 raised to 7. So the answer in the standard form is 6.4 into 10 raised to 7. Okay, now that's all in today's video on writing numbers in standard form. I've also tried to take in as many examples right from 2002 to 2010 so that you get idea about what kind of questions are asked in standard form and how you're going to write your answers, right? And as you can see, my calculations are all spread out in all the available space. I'm trying to explain to you in detail, but you need to master the technique and use as less as space as possible. Okay, fine. So that's all in today's video. If you like watching my video, please do subscribe to my channel. Thank you.